Hello all, we're picking back up with what in our book is called Section 4. And we are going to start with our prep skills, and skill 1 is to translate statements into symbols. So on this first statement it says one conservative estimate for the global rise in sea levels is over the next 100 years is 22 inches. I'm sorry, I didn't read that very well. One conservative estimate for the global rise in sea levels over the 100 years is 0.22 inches per year. So if that happens, we could call that 0.22 y, because after 1 year it would gain 0.22 inches. After 2 years it would gain 0.44 inches. After 3 years it would gain 0.66 inches, and so on. So each year it gains an additional 0.22. So 1 times 0.22 gives you 0.22. 2 times 0.22 gives you 0.44. 3 times 0.22 would give you 0.66. So in general, we could just say that this is 0.22 times however many years you have had to gain. So the next one, let's switch to a different color here. Keep them straight. So the next one says, if a new TV show got a lot of hype but turns out to stink, and it loses 700,000 viewers each week after the premiere, then negative 700,000 W represents the change. So again, after 1 week, you would be at negative 700,000 from what you originally had, viewers. And after 2 weeks, you'd be at negative 1400, okay, which would be 1,400,000 viewers, and so on. So each week, you multiply by the number of weeks it's been, and that's how many viewers you've lost. So 1 times negative 700,000 would be negative 700,000. 2 times negative 700,000 would be negative 1,400,000, and so on. So we could represent that with negative 700,000 viewers per week, or 700,000 viewers lost per week. We have to put the negative in there, otherwise we'd be gaining viewers, and we want to represent that we're losing viewers. So by putting a negative, we represent we're losing viewers. Okay, and then the next one says if 12.5 million people watch the first episode, then the number of viewers after W weeks looks like this. So it says now let's actually say how many people were starting, and then that gives us a starting value. So we started at 12,500,000 viewers, and we're going to lose 700,000 viewers per week. We can't just put minus 700,000 because that would only represent 1 week. We want to be able to repeat this for 1 week and 2 weeks and 3 weeks. And then we could determine, for instance, like how long is it going to take if they leave the show on the air before it has no viewers, that type of thing. Or how long would it take to get under 10 million viewers? We could analyze that now that we have that expression for it. So now for the second skill in our prep skills, we want to look at drawing a graph from a table of values. So this is called a scatter plot. And in this case, they went ahead and connected the dots between the scatter plot, but we don't really do that unless there seems to be a pattern, just kind of FYI. If there doesn't seem to be some sort of pattern, we don't want to make some zigzaggy connection between the points on a scatter plot. But this table displays the number of viewers for the TV show over the first 5 weeks. So in this case, the first week, when it first premiered, there were, remember, 12,500,000 viewers. So if you look at our table, they've gone from 0 to 12 because our biggest number is 10. So remember, when we're looking at that scale, we want to make sure that we at least get to 10. So they went by 2s and added a little extra there. And then for viewers, they need to get up to 12,500,000. It's going to come down from there, so that's the highest we need to go. So they went by 2 million. So 2, 4, 6, 8, 10, and 12 million, and then again went up to 14 million, so that we had enough to get to 12,500,000. So this value would be our first point, 0, 12,500,000. I'm going to leave those commas out of there because it's kind of confusing when you're listing it as a point. Okay, so 0, comma for the y, and then 12,500,000 for the, I'm sorry, 0 for the x and 12,500,000 for the y. Then the next week we have 2 weeks, or actually they did 2 weeks after the premiere. So 2 weeks after the premiere we'd be at 12,500,000 minus 700,000 twice, because it's 2 weeks. And that's where they got the 11,100. So 2 is 11,100. It's kind of hard to decipher on here whether that's 11,100,000 or just 11 million. But we just put it as close as we can. It should be just a little bit past halfway between 10 million and 12 million. And then so on. Now if we wanted to double check, we could also even put in some intermittent values. So for instance, we know that after 1 week, it would be at, this was the 11,100,000. And we know after 1 week, it would be at 11,800,000. And so if we look at the graph, 1 week would be here, down below. And if we go up, does this look like it's about right? It should be, you know, at 1 week, which is halfway between left to right, and then we should be just shy of 12 million, which we are. So this continues that pattern all the way down for 10 weeks, marking every 2 weeks. So on this next skill, I'm actually going to skip skill 3 and we'll come back to it because skills 4 and 5 use this graph, and so I think it'll be easier to do those now. So we're going to look at computing slope. And if you remember, I'm sure at some point you've had some algebra, and in algebra a lot of times they will say that the slope, which is oftentimes represented by an m, I'm not sure why we use m for slope, but it's pretty standard. And then sometimes it's written as the change in y over the change in x. Sometimes you'll see it x2 minus x1 over y2 minus y1, or more commonly, or more kind of a shorthand way of saying it is it's the rise over the run. In other words, how much does it go up and down compared to how much it goes left and right from one point to another. So what they've chosen is they have looked here at this graph and they said, let's use, since this is a line, we can use any point on this line to compute the slope. So they said, let's start with our first week, okay, or actually our 0 week, and do this as one of our points. And then let's go to week 4. And honestly, it wouldn't matter which weeks. You could do 0 and 1, 1 and 2, the 0 week and the 8th week. It doesn't matter as long as you have both values for that point. So what they did is they said, in fact, I'll compute another one after we compute this one. So it said to compute the slope using these 2 points, right here and right here. Let's do that in a different color so it's a little bit more obvious. So they're using this point and this point. And so they said, well, at week 4, we're at 9,700,000. You want to do the ending point first. Okay, so this is where you ended. And then you want to put the earlier point, in this case that's where we started. And so if you take where we ended and where we started, or the latter point minus the earlier point, you get a difference of negative 2,800,000 over 4 weeks, because we went from, we were ended at the 4th week and we started at the 0 week. So that was over a period of 4 weeks. And that gets us negative 700,000. Well, that's kind of interesting. Negative 700,000 was what we already knew that we were losing each week. Well, that's exactly because minus 700,000 is the slope. So if I compute the slope between any of these 2 points, I'm going to get that you're losing negative 700,000 per week. Let's do this for a couple other points. So if let's say we used week 0, which was 12,500,000, and we'd use week 1, which we said was 11,800,000. 11,800,000. Sorry, I keep saying 11,000 instead of 11 million. So if we did that, that would be 11,800,000 minus 12,500,000, and that would be over a period of 1 week, because we just went from week 0 to week 1, so 1 minus 0. So we ended at 11,800,000. We started at 12,500,000, so we lost 700,000 over 1 week, which again is 700,000 a week. And we could do that between any 2 points. Let me pick, we'll do week 4 and week 10. So if I did from week 4 to week 10, just erase this just so it's not confusing as to what we're looking at. So if we go from end at week 10 and start with week 4, then that would be 5,500,000 minus our earlier week, which was 9,700,000, and that was from week 10 as our ending point, and week 4 is our earlier point. So if I subtract those top two numbers, I get 4,200,000 viewers lost over a period of 6 weeks, because we went from the 4th week to the 10th week, so over 6 weeks. If I divide that, I again get 700,000 per week, or negative 700,000 per week. So I don't want you to think that when you're computing a slope that you have to pick any magical 2 points. You can pick any 2 points that are on that line and you can compute the slope. But what the slope will tell you is how much you're losing in a 1 week increment, depending on what your problem is about. In this case, ours was measured in weeks, so it was how many viewers. I'll even put that down here. So it's how many viewers we were losing per week. So negative 700,000 viewers per 1 week. So now we're going to look at interpreting the slope and the y-intercept. So remember, our slope was how many viewers we were losing per week. So each week this goes down negative 700,000 per week. So that was our slope. So remember, m, which is slope, is negative 700,000 per week. And then it says we also want to look at what's the y-intercept. Well, the y-intercept is where the graph crosses the y-axis at, and that is this point right here. So our first point is where we cross the y-axis at. And in that case, we know that that was at 0, 12 million. So the y-intercept is 12,500,000. So what's the interpretation of that? And I'm going to go ahead and write an equation for this, even though they don't ask us. So what we're saying is that the number of viewers that we would have would be equal to 12,500,000 minus 700,000 per week, which is, we had that written earlier just without the v equals. We had it written as an expression. Can't forget the w here. So 12,500,000 minus 700,000 per week. The 12,500,000, that's the y-intercept, that's where the viewing started. So that's like the initial viewers, the initial viewer number. We'll put here. Okay, so that's the initial viewer number. Then this is how many viewers lost per week. So this is viewers lost per week. So whenever you're looking at a y-intercept and a slope, the y-intercept is usually the initial or the starting value for whatever application type problem you're looking at, whereas the slope is the amount that you lose per whatever unit you're measuring your x value in. So we're measuring in weeks, and so minus 700,000 means we're losing 700,000 viewers per week. So our third skill, the one that I skipped and I came back to here, is solving linear inequalities. So if we start with an inequality, such as y plus 13 is meant to be less than or equal to 5, it's less than or equal to 5, and we want to know what y has to be rather than just y plus 13, I can treat this as if it's an equation, except for, so I solve it exactly the same way. So solve same as an equation, except for one thing. If we divide or multiply by a negative on both sides, then we have to switch the sign. So switch the inequality sign. Now you might say, why do we do that? Well, think about a situation. I'm just give two numbers. So say you have an inequality such as 5 is greater than 3. If I put negatives on both of those, negative 5 and negative 3, now negative 5 is actually less than negative 3. When you multiply by that negative, it switches what side of the zero you're on. It switches you from either being on the right, further to the right or closer to the right on the right side of 0, or further closer on the left. Let's do one where we have a positive and a negative. It's kind of interesting to see. So for instance, let's say I say negative 2 is less than 7. If I multiply both sides by a negative, I get positive 2 is in comparison to negative 7. Well, positive 2 is not less than negative 7. Positive 2 is greater than negative 7. So if I multiply by a negative, if I divide or multiply by a negative, I have to switch the inequality sign in the middle. So in this case, I don't have to do that because I'm not going to be multiplying or dividing by a negative. Y plus 13 less than or equal to 5. All I have to do is subtract 13 from both sides, and I get that y is less than or equal to negative 8. It doesn't matter that this ended up with a negative value here. I didn't multiply or divide by a negative. So that's just the final answer for that. Next one I have negative 6t is greater than 54. Now to solve this, I have to divide both sides by negative 6. Well, in this case, I did divide by a negative. So in order to keep the relationship correct, I'm going to have to switch the greater than to a less than. So 54 divided by negative 6 is negative 9. So our final solution for this is that t has to be less than negative 9. And then last but not least, 12 plus 3x is meant to be greater than or equal to 80. If I subtract 12 from both sides first, just like if it was an equation, you have to do the subtraction before you do that division. So that gets you 3x is greater than or equal to 68. We didn't multiply or divide by a negative, we just subtracted something. So we don't have to switch the sign, still a greater than or equal to. And again, we're going to divide by 3, but we're not dividing by a negative, so we can just leave this sign the way it is. And you can leave it 68 thirds is how they actually left their answer. But you could also switch it to a mixed number if you wanted to, which would be 22 2/3. So we could say 22 2/3, or we could say approximately 22.67. So x has to be greater than or equal to 68 thirds, or x greater than or equal to 22 2/3, or x greater than or equal to 22.67. Depending on what you're using your number for, may dictate which one of those is a better form of your final answer. So now we'll finish up with the prep skills questions. And the first question says to translate each statement into symbols. So according to a report on CNN Money in 2015, 869,000 new pieces of computer malware were released per day that year. Write an expression for the number released in X days. So 869 million per day would be 8 million, sorry, gosh, I keep reading the numbers wrong. 869,000 released per day would be 869,000 times D, times however many number of days. So in 1 day, 869,000, in 2 days, 869,000 twice, and so on. If you owe your parents $600 and pay them $50 per month, write an expression describing how much you owe. Well, in this case, this is we have a starting value, so we started at $600 as far as how much you owe them, and you're decreasing by $50 every month. So our starting value, our y-intercept, is 600, and then we're decreasing by our slope of $50 per month. So there's our first two answers there. The table describes the amount of money earned by a cotton candy vendor at a ballpark based on how many bags she sells. Draw a graph of the data. So I went ahead and created a graph here with number of bags along the bottom and amount earned along the side. So this is money because that's the bottom row. The x value, the input value, was the bags, so I put that along the bottom as your x value. I wanted to make sure I got to 80, so I just went 20, 40, 60, 80. And on the bottom, I wanted to make sure I got up as high as 32. So I went by tens, but then I marked in between those just to kind of help me see it a little bit better. So I have 0, 0, and then I have 28, so I'd be a little short of 10. 40, 16, which would be a little bit past 15. 60 is 24. So a little short of 25. 80 would be 32. And of course this isn't perfect because I'm doing it by hand, but these should, if you were using graph paper, they should fall in a nice straight line because we're just going up by 8 each time. Okay, so that is our graph of the data. And whenever you do a graph, make sure that you get a title, that you label each axis with what they are, what values they're representing, and also label the axes with your numbers. Even if it's, the only time that you may not have to do that is if it's by ones. If you don't mark it, that's what people are going to assume is that it's by ones. So if that's not what you mean, you should definitely mark the x and the y axis. Find the slope of your graph and decide what that means, and then find the y-intercept of your graph and decide what that means. So if we look at our graph, the slope of our graph is going to be how much it goes up per how many bags that you've sold. So for instance, it went up $8 for 20 bags. So we could use the first point and the second point. I'll use a couple different points so you can see that it doesn't matter which points you pick. But we know that it went from, or it ended at $8 and started at $0, and that's when we ended at 20 bags and started at 0 bags. Remember, the output value, the y, goes on top. It's how much we rise, how much we go up and down, which is the money in this case, for how much we run, which is the number of bags. So we gain $8 per 20 bags. Now if I divide 8 by 20, we can get how much it is per single bag. So they're making, in this case, it comes out to be 0.40, which would be 40 cents per one bag. So every bag they sell, they're making 40 cents. It doesn't necessarily mean they're selling it for 40 cents, but that's how much they've earned. So like their profit. Now, we could have picked different values. So say I wanted to do a different color here, do like a purple. Say I wanted to use, I'll use 20 and 8 again, but I'll go up and use our last point, 80 and 32. I should get the same answer because it's on the same line. So if I say I ended at $32 and I started at $8, and that was when I ended at 80 bags and started at 20 bags, that would mean I went up $24 for 60 bags. So if I divide that, 24 divided by 60, I still get 0.04 on my calculator, which if we put that in money terms, that's 0.40, 40 cents per bag. So when you're doing this slope, it doesn't matter which 2 points you pick. You can pick the first and the second one, the first and the last one, as long as you're dividing the difference in the output on top and the difference in the input on the bottom. So this is like your y value, okay? And this is your difference in your x value. Rise over run. How much it goes up and down for how much it goes left and right. So now the intercept is quite a bit easier to grab off of here. If we look at the graph, the y-intercept is just where we started. So the y-intercept, we could say it's 0, 0, or in this case, we could say the y-intercept is just 0, which means we could say that the y-intercept is $0 because you make $0 for 0 bags sold. So the y-intercept, you could either say it's $0 or you could say it's 0 bags, $0. You can write it as a point or a single value. But the value is the y value, so in this case that's the dollars. So if I'm going to write it as a single value, I should say it's $0. So now we're going to go on to the class work, and hopefully everything's going well, and you should be done soon with your 4th set of notes.
Here we're told that we have $175 to spend on food and we're buying pizzas at $9 a piece. So number 1 says figure out how many pizzas you can afford using a numerical calculation, which means no variables, just what would you punch in your calculator. Well, I would say, okay, I've got $175 and I know that these pizzas are $9 a piece, so I'm going to divide that by $9, and that's going to come out to about 19.4. Well, you can't buy 0.4 pizzas. They will not let you round up to 20 either, so you could get 19 pizzas. And then number 2 says, okay, let's think about variables. Write an equation that represents the total cost C of ordering P pizzas. Well, the cost of ordering pizzas would be $9 per pizza, so $9 times the number of pizzas, so C equals 9p. And then it asks, what does this tell you about how the cost varies? Well, we have essentially y equals kx. We have a constant times a variable with nothing added on, so this is actually direct variation. Then in number 3, we're going to use that equation to complete the table. So we're multiplying the number of pizzas by 9 to get the total cost. So 0 pizzas means $0. 5 pizzas would be $45. 10 pizzas would be $90, and so on. Then in number 4, we're going to use that table to create a graph. And then it wants us to try and use the graph to figure out where $175 is in terms of numbers of pizzas. So looking at that, 175 would hit right around here probably, and so that looks like it's somewhere between 19 and 20 pizzas, closer to 19. So then in 5, we're asked to use an inequality to determine algebraically how many pizzas we can get to spend at most $175. So at most $175 means we want to keep this cost less than or equal to $175. Well, that cost, we said, was 9 times p. So that means we've got 9p less than or equal to 175. And then we can go ahead and solve that by dividing both sides by 9, which gives us p less than or equal to 19.4, which just reinforces again that we can buy at most 19 pizzas to spend no more than $175. So then in 6, what's the slope of the line you drew? Well, looking back at the graph, we have the point 0, 0, and we could use the point 1090 to find the slope. So we'll subtract the y values, 90 minus 0, and we'll divide that by the difference in the x values, 10 minus 0. So that gives us 90 over 10, which is 9. And that's what the cost is increasing by. So that's the cost per pizza. And then in 7, what's the y-intercept of that line? Well, that line has a y-intercept right at 0, 0. And that means that 0 pizzas will cost you $0. Here we're going to do the pizza problem again, except this time it says, wait, there's also a $10 delivery charge. So in question 8, write an equation that describes the cost of the pizzas. Well, now it's still going to be $9 a pizza, but we've got to add in the $10 delivery charge. So the cost C is going to be 9p plus the $10. So we'll use that to complete the table in number 9. So 0 pizzas now, if we're adding up the bill, before we put any pizzas on the bill, we already have the $10 delivery charge. And then 5 pizzas, we plug that in, we get 9 times 5 plus 10, so that's $55. 10 pizzas, we plug that in, that's going to be $100, and so on. And then we'll use that table in number 10 to make a graph. And then if we find $175 on this graph, it looks like it's just a hair over 18 pizzas, not quite to 19. So then in 11, let's use an inequality again. So we still want our cost to be less than or equal to 175. But this time our cost is 9p plus 10. So we have 9p plus 10 less than or equal to 175. That means there's an extra step to solve this one. First I need to subtract 10 from both sides. And so that's going to give me 9p less than or equal to 165, and then I can divide both sides by 9. And that's going to give me p less than or equal to 18.3, which means I can really just buy at most 18 pizzas. In 12, so in this case, does the cost of ordering pizza vary directly with the number of pizzas? Well, no, this time it doesn't, because our graph does not go through 0, 0 anymore because of that delivery charge. And then that also means that the equation is not just k times x, we have this plus 10 added on. In 13, what is the slope of the line you drew? Well, let's go pick a couple of points. We could pick 0, 10, and 10, 100. So we'll subtract the y values, 100 minus 10, and divide that by the difference in the x values, 10 minus 0. So that gives us 90 over 10, which is 9. And that's the same slope we had before. That's still $9 per pizza, which makes sense. And then in 14, what's the y-intercept? Well, that's 0, 10 because of that delivery charge. And that may feel weird because it seems like no pizzas are costing you money, but you have to think about if you called and you'd already committed to the delivery and you just hadn't given them your order for the pizzas yet, then they could already have rung in the $10 delivery charge. In 15, we're looking back at the pizza question that had the delivery charge, and it asks us to look back at the questions that talk about the slope, y-intercept, and the equation. So first of all, the slope in those questions was 9. The y-intercept was 0, 10, and the equation was c equals 9p plus 10. And this is actually really important to make this connection that the equation actually had the slope and the y-intercept in it. And so you may have heard of the form y equals mx plus b before. The slope is multiplied by the variable plus the y-intercept, and that's going to make our life a little bit easier. So in 16, a small business had 12 employees when they opened their doors, and they've been adding employees at the rate of 4 per month. So we're going to write a linear equation that describes the number of employees after a certain number of months. So we'll have E for employees equals, well, we started with 12 employees and we're adding them, so plus 4 per month. So 4 times M, the number of months. And if you prefer to have that in the mx plus b format, we could rearrange that and have it as E equals 4m plus 12. You can write it either way as long as you can find the information you need. In 17 then, what are the slope and the y-intercept of this line? Well, thinking of mx plus b and ignoring the fact that we've used m for months, that's actually like the x here. The number that's multiplied by the variable here is 4. That's our slope. That's how much the number of employees is increasing. And then we can find the y-intercept because that's the constant added on. That's the 12. So the y-intercept is 0, 12, and that means that after 0 months, there at the beginning, they had 12 employees. And then we can use the equation in 18 to draw a graph. So first I'm going to label my axes. So the horizontal axis is the number of months that have passed, and the vertical axis is the number of employees. So when we have an equation like this with mx plus b, we can start with the y-intercept, which is 0, 12. And then the slope tells us that every time I move over 1 month, the number of employees is going to increase by 4. So at 1 month, employees will be up to 16. And after 2 months, employees will be up to 20. And so on. I've got enough points already there to go ahead and connect those points and create a line. We're looking here at a table of symptoms based on blood alcohol concentration. And in question 1, we're asked, after being arrested, someone is found to have 3.5 times the legal limit. What is her blood alcohol concentration? Well, they mentioned that in most locations, the blood alcohol limit is 0.08%. So if hers is 3.5 times that, then we're going to do 3.5 times 0.08%. And that's going to give us 0.28%. Now in number 2, they want us to think about what exactly does that mean. First of all, that's not 28%. That's really 0.28%. And that means that 0.28% of her blood volume is actually alcohol. And then in number 3, describe some of the effects or symptoms that she may be having. Well, 0.28% is not quite up to 0.3, so we'd be in the 0.20 category. Trouble walking, double vision, nausea, and vomiting. We're still looking at blood alcohol content, and we have a table here for a person who got drunk and then stopped drinking, and they have a level of 0.16 at 2 o'clock in the morning, and we're counting how many hours it's been since 2 o'clock in the morning. So we're starting with 0 hours, and then it decreases. In question 4, we're asked, what is the slope of this line? So we need to pick 2 points on this line. We could pick 0, 0.16, and 1, 0.145. And so we'll go ahead and subtract the y values, 0.145 minus 0.16. And then we'll divide that by the difference in the x values, 1 minus 0. So that's going to give me negative 0.015 over 1, or just negative 0.015. And that tells us how much his blood alcohol level drops per hour. And then in 5, what's the y-intercept? Well, that would be the value when x is 0. So that would be 0, 0.16. And that tells us what his blood alcohol level started at 2 o'clock in the morning. So then in 6, we'll write the equation. So y is his BAC, y equals, and we know that it started at 0.16 and decreased by 0.015 per hour. So that would be 0.16 minus 0.015 times the number of hours, or times x. 7 asks us to restate that in a sentence. So we're going to say, if x represents the number of hours since 2 o'clock in the morning, then our equation y equals 0.16 minus 0.015x represents the person's blood alcohol level that many hours after 2 a.m. We're still looking at the blood alcohol content equation, and in question 8 we're asked to use some of the graphing calculator features that we have to see what's going on with this relationship. So it suggests making a table and a graph. So I went ahead and did that on my graphing calculator. And both of those do seem to tell the story that they're supposed to. This blood alcohol level started at 0.16 and then decreased from there on both the table and the graph at a slow, steady rate. So then in 9, what would this guy's BAC be at 3:30 a.m.? Now remember, we're counting from 2 a.m. So 3:30 a.m. would be an hour and a half later, so that would be x equals 1.5. We can go ahead and plug that into our equation, so y equals 0.16 minus 0.015 times x, which in this case is 1.5. And that's going to come out to 0.1375. In 10, how many hours would it take for his BAC to drop below 0.08? And because we want it to be below, we're going to use an inequality. So our BAC formula is 0.16 minus 0.015x, and we want to know how long it will take for that to drop below, so less than, 0.08. And then we need to get x by itself. So I'm going to start by subtracting 0.16 from both sides, and that's going to give me negative 0.015x less than negative 0.08. And then I'm going to divide both sides by negative 0.015. And remember, when you divide both sides of an inequality by a negative number, it does turn the inequality around. So this will now be a greater than. So we're going to have x greater than about 5.33, or 5 1/3. And so what that tells me is after more than 5.3 hours have passed, he'll finally be below the legal limit of 0.08. We're still looking at the BAC equation, and in question 11 it asks, what information would you need in order to draw the graph of your equation? Well, you would either need to know 2 points on that line that you could plot and then connect, or you need to know 1 point and the slope. So then in 12, we'll use either 2 points off of the table or the y-intercept and the slope to graph the line on the coordinate system. So first I'm going to label the axes. And then if you want to, you can pick 2 points off of the table. I'm going to go ahead and use the fact that we know the y-intercept is 0.16. and then the slope is negative, so I'm going to go down as I move to the right, and it's negative 0.015. So that means that if I went over 1 hour, it would go down 0.015, and if I went over 2 hours to the next tick mark, it would go down 0.03. So then in 13, what is the x-intercept? Well, we can sort of estimate the x-intercept off the graph. It's somewhere between 10 and 12 hours. But to actually calculate that exactly, we need to use the fact that at the x-intercept, the y value has dropped to 0. So that means I can take my equation and plug 0 in for the y value. That'll give me 0 equals 0.16 minus 0.015x. And then I need to get x by itself. So in this case, I think I'll start by moving the x over to the left. So I'm going to add 0.015x to both sides. And that's going to give me 0.015x equals 0.16. And then I can divide both sides by 0.015. And that's going to give me x approximately equal to 10.67. And so what does that mean? Well, that means that it's going to take 10.67 hours for this person's blood alcohol content to return to 0. Here we're just looking at slope and what that tells you about the direction of a line. So in 14, we're supposed to sketch an example of a line with a positive slope. Well, a positive slope means that as you move to the right, it will go up. And so we'll just draw an example of that anywhere here on the graph. And then in 15, sketch an example of a line with a negative slope. Well, that means as you move to the right, it should be dropping. And then in 16, can you describe what a line with a slope of 0 would look like? Well, if positive goes up and negative goes down, then 0 would just be flat. In number 1, we've got someone who weighed 170 pounds when he started college and then started gaining weight at a rate of 0.4 pounds per month. So we're going to write a linear equation describing his weight as y in terms of months after he started college, which we'll let be x. So that would be that his weight y equals the 170 pounds that he started at plus the 0.4 pounds he's gaining per month times the number of months, which is x. So then in number 2, we're going to restate that as a sentence. If x represents the number of months since he started college, then y equals 170 plus 0.4x represents his weight in pounds after that many months. In 3, if Bubba continues this weight gain, how much will he weigh after 3 years of college? Now remember, x in this case stands for months, so the first thing we need to point out is that 3 years would be 36 months. So that's what we'll be plugging in for x. So y equals 170 plus 0.4 times 36, and that's going to come out to 184.4 pounds. And then in question 4, how long would it take to pass 200? And they want us to use an inequality. So we're going to say that we know his weight is represented by 170 plus 0.4x, and we want to know how long that would take to be greater than 200. And then we can get x by itself. So first I'll subtract 170 from both sides. That's going to give me 0.4x greater than 30. I'll divide both sides by 0.4, and that's going to give me x greater than 75. And that means that after 75 months have passed, Bubba will weigh over 200 pounds. We're still looking at this equation of Bubba's weight gain, and in question 5 they ask us to draw a graph of the equation. Now in this case you could use the y-intercept and the slope from the equation itself, but the slope is so small that it may be easier to plot some points. We don't have a table, so we're going to need to create one for ourselves. First of all, let's get the axes labeled. And then I'm going to create a little table of values for myself. Remember that our equation is y equals 170 plus 0.4x. And so if we plug in 0, we get that y-intercept of 170. And then we can just pick a couple other x values to plug in. So maybe 60. 170 plus 0.4 times 60 gives us 194. And then maybe 120, and 170 plus 0.4 times 120 gives us 218. So that gives us some points to plot to create this graph. So then in 6 we're supposed to find the slope of the line. Well, looking at the equation and thinking about y equals mx plus b, the m, or the slope, would be the 0.4. And what that means is that Bubba is gaining 0.4 pounds per month. And then in number 7, find the y-intercept. Well, again, looking at that equation and thinking about y equals mx plus b, the mx is the 0.4x, so the b is the 170. That means the y-intercept is 0, 170, and that's his starting weight at 0 months, so when he first started college. So now instead of weight gain, we're going to look at weight loss, and we're given a table with number of calories burned and weight. And question 8 wants us to find the slope of the line. So we'll pick 2 points or 2 rows from this table, and we'll start by subtracting the y values. So 196 minus 200, and then we'll divide that by the difference in the x values, so 14 minus 0. So that's going to give us negative 4 over 14, which reduces to negative 2 over 7. So that's the slope. Now in number 9, we need to find the equation. We know the y-intercept from the table. That's 0, 200. So we can put all of this together. We have y equals mx plus b. So y equals our slope, negative 2/7, times x plus our y-intercept of 200. And then in 10, we'll restate that in a sentence. So if x represents thousands of calories burned, then our equation y equals negative 2/7 times x plus 200 represents Bubba's weight if he burns that many calories. We're still working with this weight loss formula for Bubba, and in 11 we're supposed to use the equation that we just found to find Bubba's weight if he burns 50,000 calories more than he consumes. Now remember that our formula was y equals negative 2/7 x plus 200. Y is going to give us his weight, and x is in thousands of calories, and that thousands of calories is important because if he's burning 50,000 calories, that means our x value is really just 50. So we're going to go ahead and plug that in. Y equals negative 2/7 times 50 plus 200. And that's going to give us 185.7 pounds. Now in 12, we're supposed to use our equation to find out how many extra calories he needs to burn to get back to the weight at which he started in college. So the first thing you need to do is remind yourself what that was, and that was 170 pounds. Now weights are the y values in our equation, so I'm going to put that in for the y. 170 equals negative 2/7 x plus 200. And then the first thing I need to do to solve that is subtract 200 from both sides. So we're going to get negative 30 equals negative 2/7 x. Now we need to think about how to solve that from here. With fractions multiplied times your variable, you want to multiply by the reciprocal. So we need to multiply both sides by negative 7/2. And so that's going to give us x equals 105. Now remember, x values are in thousands of calories, so that's actually 105,000 calories. In number 13, so if we know that he needs to burn 105,000 extra calories, and then a man of his size would burn about 755 calories when running for an hour, how many hours of running would that take? So let's start with the 105,000 calories that he needs to burn. And then we can multiply that by a fraction that says he burns 755 calories in an hour. Now we need the calories on the bottom so that they'll cancel. So the calories cancel, and we'll take 105,000 divided by 755, and we'll get about 139.1 hours. And then in 14, based on this activity, what would have been his best approach when starting college? Well, it takes a whole lot of effort to burn it off afterwards, so it would have been more effective if he'd exercised and watched his calorie intake all along so that he wouldn't gain it in the first place. So we have a movie download service. It has a $14 monthly fee, and then it costs $3 to rent each movie. In 15, if we model the cost Y of renting a certain number of movies in a month X, so Y is the cost and X is the number of movies, what is the slope? Well, the slope then would be the cost per movie, and that's the $3. And then in number 16, what is the y-intercept of the line? Well, the y-intercept would be the starting amount, or that monthly fee, so $14 or 0,14. And so then in 17, let's put that all together into a slope-intercept form of an equation. Well, that would be y equals mx plus b. So y equals the slope times x, so 3x plus the y-intercept, which is 14. So y equals 3x plus 14.